Hi everyone. Um, Today's class is the first lesson for trigonometry. I want us to discuss these four cases: the trigonometric ratios, definitions, identifying the sides, then the inverse trig ratios. All right. Trigonometry is one of the most confusing areas in mathematics that students usually face. So it takes the courage for someone to understand trigonometry. But because here is the beginning, then I hope we can have a very good class. Yes, not just today, but in the subsequent videos. So here is the beginning, saying I like trigonometry, I don't like it, I've treated this one before, or I never did it before. We are starting trigonometry. All right. And the first thing we need to understand is the ratios, trigonometric ratios. All right. So which are the trigonometric ratios? These are the ratios that we are dealing with in trigonometry. The reason the name is titled as trigonometric ratios. Okay. The first one is sine. The second one is cosine. And the third one is tangent. Yeah, of course, they are very much unique when you hear them, especially if you never did trigonometry before. These are the three basic trigonometric ratios. They are not the only ratios we have, but they are the basic trigonometric ratios. All right, we have sine, we have cosine, then we have tangent. Okay, but whenever we want to solve a problem, we don't write SINE. Instead, we reduce it to SIN. Yet, we don't pronounce it as sin. Mind you, it is pronounced out as sine again, as sine again. Sine in short form is sine again. Okay. Now, this is cosine. The short form is cos. Yeah, when we are applying cosine in mathematics, we don't have the time to be writing cosine this, cosine this, cosine this. Instead, we reduce it to cos. Then tangent. Tangent, it is reduced to tan. Yeah. So these are the short forms for what? The three basic trigonometric ratios. Sine in short is also sine, though it appears to be sin. Cosine is cos, tangent is tan. Okay. Now, these ones, there is no way they can stand the way you see them when solving math problems or when discussing trigonometric cases. They go with angles. They go with angles. So if we want to have an angle like this, let's say this one is a right angle triangle. Right angle triangle. And there is a given angle here. Let us call it alpha. Yeah. Let's call that angle alpha. It could be theta. It could be beta. Okay. So if we are discussing this triangle, we cannot just say sine, something like that. No. We have to say sine with an angle. So we can say sine theta. Sorry, sine alpha. So this one is pronounced as sine alpha. This one is pronounced as cosine alpha, but in short we say cos alpha. And this is tangent alpha. Then the short form we say tan alpha. So the three basic trigonometric ratios are sine, cosine, and tangent. In short form, sine, cos, and tan. When discussing them with a specific angle, for instance, let's say alpha, we say sine alpha, cos alpha, tan alpha, or sine theta, cos theta, tan theta, or sine x, cos x, tan x. Okay. Now, these are the three basic trigonometric ratios. Let's go to the definitions. How do we define these three ratios? How do we define them? Well, we can only define these ratios with a right angle triangle and a given angle. Let's say here is a right angle triangle. Right angle triangle. Why right angle? Because we have exactly 90 degrees. Why triangle? Because there are three sides. So a triangle with one of its interior angles exactly 90 degrees, we call it right angled triangle. And only in a right angled triangle, we have the right to discuss sine, cosine, and tangent. Okay. Now let's choose a specific angle. We can choose to say theta. Okay, theta. The angle name doesn't matter. Sine remains sine. The angle name doesn't matter. Name doesn't matter. Cos remains cos. Tangent remains tangent. Okay. Now that we are using theta, let's just change them to theta. Sin theta, cos theta, tan theta. Now we want to define sin theta. We want to define cos theta. We want to define tan theta. We want to define them. Okay, so if we want to define them, the first thing we need to do is to identify the sides. Identifying the sides. We have three sides. The first side I want us to identify is the side that is opposite to the given angle. 90 degrees, we don't call it a given angle because no math teacher can change it. No one can change that 90 degrees because it is because of this 90 degrees, this triangle is called right angle triangle. So we cannot decide. Once we agree that we are dealing with a right angle triangle, the 90 degrees is a must. So we don't call this one a given angle. This is what we call a given angle because it is what we can decide. I can decide this to be 60 degrees. You can decide this to be 30 degrees. Your teacher can decide this to be 48 degrees. Any other person can decide any other angle, but no one decides this because once it's a right angle triangle, it must be there. We don't negotiate it. Okay. Now, this one is a given angle. So now you know what a given angle is. Any side that is facing the given angle, it is what we call opposite. I don't want to write the full word opposite. Any side in a right angle triangle that is facing, that is opposite the given angle is called the opposite. Okay. Now, I want us to identify the other side. Between the given angle and the right angle, when we say right angle in geometry, it means 90 degrees. I've made videos on geometry. I've made two videos for just introduction, explaining all the basic terms. Between the given angle and the right angle, between this side is what we call the adjacent. Adjacent. This is the adjacent side. Why is it so called? It's because it's between the given angle and the right angle. This is the opposite side. Why is it so called? It is facing, it is opposite the given angle. And this side that is opposite the 90 degrees, opposite what? The right angle, the 90 degrees, is what we call the hypotenuse side. The hypotenuse side is what we refer to as the longest side of the three. Okay, so always hypotenuse side, the opposite side, and the adjacent side. These are the sides we use to define the basic trigonometric ratios. So now let's go to the definition. Sine theta, cos theta, then tan theta. These angles, these ratios were defined long time ago. It's hundreds, thousand, over 1,000 years when we had these definitions, when these definitions were defined, when these ratios were defined. So sine is understood to be the opposite over the hypotenuse. So that is why they are called ratios. In mathematics, when we say a ratio, we mean a fraction. And it's the reason we have the word we call rational. When we say rational, we mean a fraction. For example, a rational number, a number in the form A over B. So it's a ratio. Okay. Now, sine theta, sine alpha, sine beta, sine x, sine p, sine 60. As long as it is sine, the ratio says opposite over hypotenuse. Cosine of any angle, be it theta, be it gamma, be it lambda, be it rho, be it any letter, any symbol. The most important thing is cos. It is what? Adjacent over hypotenuse. Now we come to tan. Tangent of any angle, irrespective of what is attached to it, whether a symbol, whether a Greek alphabet, English alphabet, a specific number, whatsoever. Even if you say tan pi over 2, no matter what, tan is the opposite over adjacent. Okay. So these ratios, you need to be able to remember them. For me, I was not lucky as you are. Maybe I started discussing this when I was in my junior school, the third level, JSS3 from 3, level 3. Okay, so sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Okay, when you are a beginner to trigonometry, because of the language, the words, they are strange, they are very new to you, you find it difficult. Especially that one usually confuse people that they cannot even remember these ones. So what technique do we use to be remembering all these ratios? So what do? Sine starts with S, opposite starts with O, and hypotenuse starts with H. So what do we say? We say SOH. SOH. We all know that in English, when we say SO is so, but we can use the word so here just to remember something. Yeah, SOH, so. So even if you are in the cinema, you are watching football match, you are anywhere, someone asks you, yeah, please, my friend, remind me again, what is the ratio for sine? Say, oh, sine is simple, just remember so. SOH, sine of any angle is opposite over hypotenuse. Now you want to remember cos, CAH, CAH. This is not actually car, CAR, but what? You can use car as a word to remember this, CAH. I know you cannot use CAR because that doesn't like R. Please be careful. CAH. CAH means cos is equal to adjacent over hypotenuse. And the last one is TOA. TOA. Toi. I think toi is a French word, right? Toi. Toi. Yeah, toi. Moi, toi. I think toi is you. All right. Mind I cannot speak French. Toi. So now if you want to remember them, say so, ka, toi. So, ka, toi. Now, if someone covers the board and asks you, what is the ratio for cos? Just say, oh, cos, CAH. Cos is adjacent over hypotenuse. That's good. Now, someone asks you, what is the ratio for tan? Oh, tan. Okay, just let me remember TOA, toi. Tan is opposite over adjacent. Very nice. So, you see, so ka, toi will help you to remember sine, cos, and tan. Very much important. So the next thing we do, identifying the sides. Yes, identifying the sides. How do we understand this is opposite? Okay. Okay, let me start with a similar one. Let me start with a similar one. All right. We want to identify the sides. Which of the three sides is the hypotenuse? Which of the three sides is the opposite? And which is the adjacent? All right. Do not memorize this format saying on the right is opposite. No, 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 no. Don't do that. At the bottom here is the adjacent. No, 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 no. Out there is the hypotenuse. No, no, that's not the way. Go according to the way I'm saying it now. Opposite is the side that is opposite to what? The given angle. Our given angle is theta. So you cannot say because opposite here is on the right, so the right has to be opposite. No. Opposite is not the right hand side. Opposite is the side that is facing the given angle. Look at the given angle. It is faced by this side. Opposite. Look at the given angle. It is faced by this side. Opposite. So here is our opposite. Good. Now, adjacent is not what we have at the bottom, but rather what? It is between the given angle and the right angle. So where is the given angle here? Look at the given angle. Where is the right angle? Look at the right angle. So between given and right angle, between given angle and right angle, look at it. It is the adjacent. So do not say adjacent is on the right. No. Hypotenuse, it is the longest side. And it is the side opposite what? The right angle. Look at the right angle. So here is the hypotenuse. So easy. Do not remember them by which side they are, no, but by what I'm saying. Which side is opposite the given angle, between the given angle and the right angle. Let's try another one. Let's say we have this. Yeah, and the given angle, let's call it alpha this time around. So which of these three sides is the opposite? Opposite is the side that is facing the given angle. Look at the given angle. So here is the opposite. Adjacent, it is between the given angle and the right angle. So here is the adjacent. Hypotenuse, it is facing the right angle. So here is the hypotenuse. Okay, so let's try another one here. Okay, now I want to identify the opposite, the hypotenuse, and the adjacent. Yeah, let us start with what? The opposite. Where is the opposite here? Huh? Where is the opposite? This, we cannot get any opposite here. There is no opposite here. There is no adjacent. Why? Because there is no given angle. When you remember how I used to explain the positions for opposite and the adjacent, I used to say what? I used to relate any of them with the given angle. Opposite is a side facing the given angle. Adjacent is a side between given angle and right angle. So if there is no given angle, it means there is no opposite and no adjacent. How about the hypotenuse side? There is always hypotenuse side because there is a right angle. So here is the hypotenuse, but no given angle. So now that there is a given angle, let's call it beta. Then now we can say Is this the opposite? No. The opposite is the side that is opposite to the given angle. So look at the given angle, and here is the opposite. Between the given angle and this one is the adjacent. Okay, so the last one. Yeah. Which one is the opposite here? Which one is the hypotenuse and which one is the adjacent? Well, the fact that the triangle is not a right angle triangle, there is no opposite, there is no adjacent, and there is no hypotenuse, because we cannot discuss these ones once it is not a right angle triangle. So the fact that it's not a right angle triangle, we cannot identify any of the sides. Okay, so we are done with identifying this. Let's go to the inverse ratios. Let's go to the inverse ratios. These three ratios, they have inverses. Let's see them. Let's see the inverse ratios. When we talk about inverse, like the inverse of 2 over 3 is 3 over 2. The inverse of 1/4 is 4 over 1. The inverse of s over t is t over s. T over s. So we can say the inverse of sine is cos, is cosecant. The inverse of sine is what? Is cosecant. So this tells us that cosecant is equal to 1 over sine. The inverse of sine is cosecant. So this tells us that cosecant is equal to 1 over sine. So, but the short word for cosecant is cosec. And the short word for sine is also sine, but spelled differently. So if you choose to have a particular angle, let's call it cosec theta, then here is supposed to be 1 over sine theta. So if your friend says, yeah, my friend, what is cosec 30 equal to? Well, cosec 30 is equal to 1 over sine 30. What is cosec 40 degrees? It is equal to 1 over sine 40 degrees. What is cosec x? It is 1 over sine x. So generally, cosec is 1 over sine, simply because the inverse of sine is cosecant. So the inverse of 1 over 5 is 5 over 1. The inverse of 1 over 5 is 5 over 1. So the inverse of 5 over 1 is 1 over 5. So if the inverse of sine is cosecant, then the inverse of cosecant is also sine. So we can deduce that sine again is equal to 1 over cosec. Very interesting. If the inverse of cosec is sine, then the inverse of sine is cosec. So if cosec is 1 over sine, then sine is 1 over cosec. We can prove that one mathematically. Let's see. Now we say cosec theta is 1 over sine theta. So why sine again is 1 over cosec? Let's see. So what do? We give this one, then we cross multiply. Yeah, cosec multiplied by sine. You can choose to start with any one. Cosec theta, sine theta. 1 times 1 is 1. But we want to make sine the subject. So if you want to make sine the subject, we divide both sides by cosec theta. Cosec theta. So it goes, so we say sine theta is 1 over cosec theta. So this one tells you that if the inverse of sine is cosecant, then the inverse of cosecant is sine. Now let's go to the second one. The inverse of cosine is secant. The inverse of cosine, remember we have sine, cosine, and tangent. So here we have to go for the tangent. The inverse of cosine is secant. So this tells us that secant is equal to 1 over cosine. Secant is equal to what? 1 over cosine. Why? Because the inverse of cosine is secant. So what is the short form for secant? Is sec. Sec. The short form is cos. So if we choose to attach a particular angle, we can say sec theta is equal to 1 over cos theta. So likewise as we did here, if the inverse of cosine is secant, this implies that the inverse of secant is cosine. So it means if sec is 1 over cos, then cos theta is 1 over sec theta. Yeah. So what is important here is these two are important. You need them, and this again, you need it. Most cases, you need to master this one. You need to always mark this one. So the third one says the inverse of tangent is cotangent. So what does that imply? It implies that cotangent is 1 over tangent. So the short form for cotangent is cot. And tangent, we know it's already tan. So if we give them angles, we say cot theta is 1 over tan theta. Cot theta is 1 over tan theta. So if the inverse of tangent is cotangent, so it means the inverse of cotangent is tangent. So what does that imply? If cot is 1 over tan, then tan is equal to 1 over cot. So you need to always remember this. You need to always remember this. So thank you for watching. Don't forget to like and share. Bye-bye.